we're going to be learning about balanced and unbalanced forces. Now, we talked about the girl skydiving. We talked about this girl skydiving, and she had balanced forces. She was skydiving inside. Okay. Now, we answered these questions last class, but let's do them again. Could someone read the first question and answer it? Let's start off with Daisy. Could you read the first question and answer it?
Pushes have different strength and directions. Yeah.
Yeah, you can push things with different strength. Very good. And now let's have Sarah. Can you read the second question?
Can push and pull train the seat or direction of the
Motion.
and stop it.
What do you think? Can a push or a pull change the speed or direction of an object is kind of what they're asking. If you push something, will it go faster or slower? Think about it. If you're riding your bike, Sarah, and I push you, Sarah, let's say you're riding your bike and I push you really hard, will you go faster or slower?
Faster.
Faster. So can a push change the speed?
Yes.
Yes. Pulls can also do that. If you're riding your bike and I pull your bike, you might go backwards, changing your direction. Guys, the way I want you to think about this, though, if an object is being pushed or pulled, it can cause motion. If I push this bottle, it can cause motion. Okay. Now, what happens when objects touch or collide? Can someone read the last question and answer it? Taylor.
What happens when objects touch or collide?
What happens?
I think in my head that I have an example like two bouncing ball bounce together and it's blocked out. I think so.
Yeah.
Or maybe a hard thing like a table. If it touch each other, it will not move.
Okay, yeah. So like, yeah, if my phone falls on the table, it will stop movement. Yeah, different things happen when different things touch or collide. So they start to push on one another and can change the motion. Okay. Imagine two cars running into each other. They're gonna both push on each other and change that car's motion. Okay, guys, let's look at the picture. There are 4 pairs of contact forces. Label the forces by drawing arrows. So, to show you an example, so arrows that are pointing towards each other, like this. This is I believe this is a pull. It's a pull because they're pulling together. And then we'll make these 2 arrows our push. So the top is our pulling together and our push is push away. So what is happening with the dad pushing his daughter on the swing? What is that? Is that a push or pull? Kim, what do you think? Is this a push or a pull?
It is a push.
It is a push. So I'm going to draw the arrows pushing away from each other. She's pushing his daughter away. Thankfully, gravity and the swing will bring his daughter back. Okay, now let's do another one. Okay, how about this one? What type of force is this? Let's have Blue Moon. What type of contact force is this? Is this a push or a pull?
Pull.
It is a pull. So let me draw the pull. I'm gonna draw 2 arrows pointing at each other. Very good. He's pulling it towards himself. He's pulling it towards himself. And how about the girl with the bat? The girl and the boy. Is this a push or a pull? Let's have Jack. What do you think?
I think that is a push.
It is a push. Very good. Okay, and the last one, we have a mom doing something. Moon. Is this last one a push or a pull?
Push.
It is a push. So the arrows are going to go away. Now these are all contact forces. Does anyone know why they're called contact forces? Moon, do you know why they're called contact forces?
No.
Okay. What does it mean to make contact? What does it mean to make contact? Does anyone know that word? Ray, do you know what it means to make contact?
Contact is when we push it or pull something that we have to touch it to it.
Exactly, you have to touch it. That's all it is, guys. Contact means touch. So these forces are all people touching the object they are contacting. The boy is holding the wagon. The dad pushed the swing. The mom is pushing the baby. They're contacting the object. Okay, these are called contact forces. Now let's read about the contact force. Touchy, touchy. Sam, can you read the first sentence?
If you push or pull an object by touching it, you apply a contact force to it.
Yeah, can you say the word apply?
Apply.
Yeah, apply a contact force. Let's have Rose. Can you read the next sentence? Rose.
When you use a contact force to push an object, the object push back.
Okay. And then the last sentence. Lisa, can you right here? Can you read this sentence? If you pull
Pull on an object, the object pulls you.
Very good. Okay, guys. So yeah, when you push on an object, it usually pushes you back. Now, the best way to do this, guys, okay, is I want everyone to stand up. What I'd like you guys to do is squat down, lower yourself, and jump up as high as you can. Jump up as high as you can. I'm gonna see who can jump the highest. I'm gonna watch your cameras. I wanna see who can jump the highest. Okay, ready, set, go, jump. Okay, one more time, jump. Okay, I think Puppy had one of the biggest jumps. I think Puppy actually had one of the biggest jumps. Good job, Puppy. So guys, when you pushed on the floor, what happened? When you jump, you're pushing on the floor. What happens to your body? What, Fia?
When I do it, I will feel I'm flying in the air.
Yeah, you fly in the air. So guys, the reason why is because when you push on an object, it pushes back on you. You push on the floor actually pushes back on you, causing you to jump into the air, causing you to go into the air. When you do a push up, if you guys have ever done a push up, you're pushing on the floor and the floor pushes back on you and you go up. And now if it's a smaller objects, when I push on them, they move, but they're also pushing back on me with the same amount of force. But I'm strong enough so I don't move. Now let's fill in the blanks. Write the correct answers from the word bank to complete the sentences. I would like everyone to read both sentences and try to figure out the blanks. I'm going to give you read both sentences and try to figure out where the word push, pull, toward, and away. Okay, let's have pasta. Pasta, could you read our first sentence and fill in the blanks?
When you push on an object, it moves farther away from you. It moves farther away from
Okay,
you.
away from. Away from. There you go. Thank you.
When you pull on an object, it moves closer toward you.
Very good. Scarf, can you please read both sentences for the class?
When you push on an object, move farther away from you. When you pull an object, it moves closer towards you.
Thank you. And I'll have one more person read it for the class. Alex, can you read it for the class?
When you push on an object, it moves farther away from you. When you pull on an object, it moves closer toward to you.
Thank you, Alex. Okay, what does it mean when something is balanced? I have some visual examples. Try to describe this to me. Describe this to me. Let's have Jack.
Balance me.
It means equals. Very good. It means equals. If you lose your balance, Jack, what happens? If you were to lose your balance, Jack, what would happen to you? If you lost your balance, let's say you're running and you lost your balance, what would happen?
I will run slower.
You would run slower, but you might fall, right? You might fall and hit the ground. Yeah. Guys, you actually have liquid. You have liquid in your ear that helps you balance. Some people lose that ability to find their balance and they're falling all over the place. That's not good. So these are balance forces. Who can read the definition for me? Let's have Daisy.
Balanced forces are equal in size and opposite in direction. When forces are balanced, there is no change in motion.
Very good reading, Daisy. So here's an example. These two guys are pushing the box with the same amount of force. Do you guys think the box will move? Sino, what do you think? Will the box move if they're pushed? No, because balance forces do not have movement. Okay? The box is not going to move. They're not going to be able to push it. They're going to push the same amount, with the same amount of force.
And also motion, no, don't have to.
Yeah, with motion, there can be two forces on an object with motion, but not if they're in the opposite directions. They have to be in the opposite direction. This guy is pushing towards the right, and this guy is pushing towards the left, and they also have to be pushing equally. If this guy was pushing harder, the box would go to the right. But if this guy was pushing harder, the box would go to the left because it's going to go towards the harder force. Is this a balanced force? Is the pineapple right now experiencing balanced force? Let's have Misha. Misha, is the pineapple experiencing balanced forces right now? So the first thing you can ask, Misha, is the pineapple moving? Does it look like the pineapple is moving, Misha?
No.
No. So the forces are probably balanced. What are some forces on the pineapple, Misha? What's something that pulls everything down to the ground? It starts with a G. A G.
Gravity.
Gravity. Gravity is pushing the pineapple down. Very good. What's stopping it from going to the ground? Why is it not on the ground? Why did it not hit Earth? What stopped it?
People.
A table. So yes, and is the table pushing on the pineapple or pulling on the pineapple? Is it pushing it up or is it pulling it down? So what did the floor do when you jumped up into the sky? Did it push on you or did it pull you? It's a push. Good try though. Good try. Very good try. It is a push. Remember guys, the floor, tables, they push on objects. The earth, they push on objects. Okay. So this is gravity. This is the push, the table pushing on the pineapple. Okay, is this a balanced force? Let's have Emma. Emma, is this a balanced force?
Yes.
Yes? Okay, I'm gonna call on
No.
someone else. No? Why?
I don't know.
Okay, that's okay. Taylor, what do you think?
I think it's a unbalanced force because that one is a big dog and one is a small cat, and it's not a balance.
Yeah, it's not balanced. And what's happening to this toy? Is it moving? Moon?
Yes, because the dog and the cat are trying to get it.
Yeah, what are they doing? Are they pushing on it or pulling on it?
Pulling on it.
They're pulling on it. Very good. And let's have Jack. Can you read the sentence for me, the definition? Can you read the definition for us, Jack Fu?
When the force acting on an object are not equal. Sign say that they are
Unbalanced
forces.
forces. Very good. So guys, when two forces are balanced, the object does not move, like my phone on my hand. But if the forces aren't balanced, if they're unbalanced forces, like if I let go, the object moves. Okay? Which one results in the change in an object's motion? We've already talked about it. Is it unbalanced forces or balanced forces? Which one results in a change in the object's motion? Who can answer the question? Let's have Banana.
Which one result a change in the object method?
Which one, Banana? Balanced forces or unbalanced forces?
Balance.
Not balanced. Let's see who else can give it a try. Let's have Zook. Zook, which one changes the object's motion? Is it the balanced forces or unbalanced forces? Which one? Motion means moving. Which one has something moving?
Balanced forces.
Are the rocks moving?
No.
No. So that's not right. Which one is moving?
Unbalanced forces.
There you go. The dog toy. Very good. The dog toy. Unbalanced forces. Very good. So guys, look at the movement. Okay. I want you guys to pay attention. If there is no movement, the forces are balanced. Forces are balanced. If there is movement, the forces are not balanced. Which direction does the object move when forces are unbalanced? Which direction does the object move when the forces are unbalanced? Let's look at the picture of the dog and the cat. Which direction does that toy move? Let's have Daisy, which direction is that toy moving? Is it towards the dog or the cat?
The dog.
The dog. And does the dog have a stronger force or weaker force than the cat?
Stronger force than the
Yeah.
cat.
Yeah, so do you think the object moves towards the stronger force then?
Yep.
Yes. The object always moves towards the stronger force. If I'm pushing on an object, if two things are pushing on the object, but I'm pushing more with my right hand, then the object will move towards the right. Okay. Now we have a little bit of a demo. Let's do it really quickly. So guys, if you guys get the PowerPoint this weekend, you can click on the 5-minute demo and it will allow you to play the games you see me playing for 5 minutes, okay? But if your parent signs up to the website, you will be able to play for free for 30 days, okay? These are all the physics experiments we do in class. Let me show you this one. This is called Sled Wars. Okay, so we have a sled and we can change the mass or the weight of the sled. We can make him fatter. I don't know how big we can make him. Oh, 200 is the max. We can make him 200 or we can only make him 10. Look how small he is now. Okay, which one will have more force? 10 kilograms or 200 kilograms? Which one will have more force? Sophia?
200.
200. Let's test it out. First, let's launch our 10 kilogram guy. Let's see how much, let's see him hit the snowman. Oh, he did nothing. He did nothing. Okay, let's restart. Let's go to 200. So this has more force. Sophia says 200 kilograms will have more force. Let's check it out. Boom. We smashed the snowman. He has more force. The bigger you are, the more force you have. Oh, we can lift him up. Okay. So guys, do you think the height, how do you think the height is going to affect force? If I put him down at 5 meters, is he going to have more or less force than
Less.
50 meters? Everyone. With you guys.
Less box.
Okay. We have less force. You guys have answered less force. Let's check it out. This is at 5 meters. We're going to keep him at 200 kilograms. Oh, he only made it through 1. He didn't even make it the whole way. But let's try 50. Whoa, he made it through all 3 and he went off our screen. What force is acting on the sled? What's causing the snowman to go down the hill? Blue Moon, what force is causing this much? Why is this sled going down the hill and hitting the snowman? What force is that? But what's the force that's unbalanced? Which is the strongest force right now on the sled?
More force.
More force, but what is it? What's it called? What's the force's name?
Contact force.
Is it magnetic force? Is it friction? Is it gravity? What is it?
It is contact force.
It's a contact force. It's not, well, I'm gonna call on someone else. Okay, Bunny, what force is acting on the sled?
I think it is friction.
Nope. What makes all objects fall to the ground? Starts with a G. Okay, we need Blue Moon. What is it?
Gravity.
It's gravity, guys. It's gravity. Gravity pulls you down to the ground. Gravity is pulling the sled straight down. Oh, but what stops it? The slope stops it and changes the direction of the force. It pushes on it and comes down. Let's increase our snowmen to 6. And let's hit our snowman. Gravity pushes him down, and then he can destroy the snowman. Okay, guys. Let's go over our last slide, and then we will be done. Okay, I want you guys to circle the unbalanced forces. Circle the unbalanced forces. Okay. And 3, 2, 1, go. Circle each one once, only once. Circle the unbalanced forces. Yeah, he's not very balanced. There's more than one. Very good. Sino, good job. Sam, good job. Bunny, good job. Sam, I think Sam and Sino get first place. Good job. Okay, it looks like you guys found them. This is wrong. Let me erase these. There you guys go. It's these 3. Okay. So the rocket is an unbalanced force. The rocket is shooting harder than what? Gravity. Remember, the rocket has to beat gravity.